In previous sections, we discovered that to solve a quadratic equation, we can do it in two ways. One of them was by factoring the polynomial expression, and the other one was by applying the famous quadratic formula. This, completing the square, is an alternative method. And this method appears when we have an expression that we cannot identify as a perfect square trinomial. So the main objective that we're going to have in here is transform this expression into something that is going to become a perfect square trinomial. So the element in here, this letter K, will be a square, and then we could factor this as a perfect square trinomial with this format. Okay? And if it is a subtraction, then we can also do it by copying a minus in here. So we're going to go from an expression that is written like this into an expression that is written like this. Okay? It's a very, very easy process to do, so let's pay attention because there are some tips that we can use on it to simplify our work. For example, let's write a perfect square trinomial by completing the square. So we're going to use the method that is called completing the square. What are we going to do basically? Let's pay attention to example number 1. Example number 1 tells me that I have the expression x squared plus 14x. As you can see directly, the expression is not a perfect square trinomial. It is a binomial, and I need to make it a perfect square. So the trick in here is the following. We identify the value of b, which is 14 in this case. And then we will take 14 and divide it by 2. Once I divide it by 2, I will obtain the answer 7. And then this 7, we are going to square this value to obtain 49. So once I have this 49 in here, what I am going to do is add that 49 to the expression, to the original value. So x squared plus 14x plus 49. How do I know that this is a perfect square trinomial? Okay, because this is the process of completing the square. Here we finish it. What we're going to do right now is prove that the polynomial that we obtain is a perfect square trinomial. How do we prove it? If you remember the factoring process, we identify the root of the first one, we identify the root of the last one, which is 7, and the one in the middle needs to be 2 times the first value and the last value. As you can see here, we have 14x. So this is how we identify a perfect square trinomial. Therefore, if I want this to be factored, because I want it written like this, the answer will be x plus 7 to the second power. And this will be the factoring of this expression that is a perfect square trinomial. Let's analyze a second case. Example number 2. Example number 2 is y squared minus 18y, just like that. Okay? A binomial. So let's convert it into a perfect square trinomial. Let's remember, we identify the value of b, and in this case b is negative 18. So we take negative 18 in here, we divide it by 2, and then the answer will be negative 9. What are we going to do with this negative 9? We're going to square it. So let's remember that when we square a negative number, we do it by putting the negative number inside a parenthesis. And when I square it, the answer results into 81. So now that I have my perfect square trinomial in here, I add this element to the original expression. So you will have y squared minus 18y plus 81. Here we completed the square. This is the final answer. What I'm going to do right now is just check that this answer falls into the rule of a perfect square trinomial. If you remember, the root of the first element, which is y, the square root of the last element, which is 9, and in the middle we're going to do a checking. 2 times the first element times the last element. And this in here is equal to 18y, which is exactly the same as the expression that I have in here. Once this is checked, then I can write it like y minus 9, because in this case we have a subtraction, and this to the second power. Remember, this is the factoring of the expression that is a perfect square trinomial. Now, with these two examples, the very convenient situation was that the first element was equal to 1, the leading coefficient. Now I'm going to do an example in which the leading coefficient is not equal to 1. It's a different number. So we're going to take in consideration an extra step for the problem. So let's analyze example number 3. Example number 3 goes the following way. We have 4x squared plus 11x, and we need to complete the square of this expression. Now, the problem in here is that I have this 4. But it's just a very small problem that we can eliminate it by doing the following. We divide all the expression by 4. Why do I do this? So that I can apply the procedure that we just did before with examples 1 and 2. So this expression now becomes x squared plus 11/4 of x. So what we're going to do now is identify who is b in this case, and it is 11/4. So we're going to take in here 11/4, and this expression we're going to divide it by 2. Remember, we were always dividing by 2. Now, 11/4 divided by 2 will be equal to 11/8. You can do it by the division process, by writing it like a fraction, and you will always get to 11/8. Now, remember, this expression in here needs to be simplest form, always. Once I have the 11/8, then I need to square the value. So what we're going to do in here is take the 11/8 and square it. Once I square it, then what I have is 121/64 due to the powers, the property powers of quotients, okay? 11 to the second power and 8 to the second power. So here we have the expression that I need, okay? So this 11/8 squared, which is 121/64, will go added to the expression. 121/64. Now comes a big problem. And in here, I need you to pay very close attention. If you look at the previous exercises, we're going to see a tip on the problem in here. I need to factor this one. The square root is x, and the square root of this one will be 11/8. Now, if you take a close look, you grab the two values, and in here we're going to check if this is a perfect square trinomial. So what we're going to do is multiply 2 by x by 11/8. And in here, if you multiply this expression, you end up having 11 over 4x. So this is the factory. And we are proving that this is a perfect square trinomial, even though we have a fraction. So fractions shouldn't scare us in this type of problems. How are we going to factor it? Okay, we already know the process. Okay? X plus 11/8 and this to the second power. So remember, here we have the process of completing the square. This is my perfect square trinomial, and this is the factoring of this one. So I hope that you understood the process. This is a case in which we have a leading coefficient different than 1. So what we always do is divide by the value that is always in here. If it is positive, if it is negative, if it is 1 million, if it is negative 1 million, whatever number it is, you divide it. You divide all the expression by the leading coefficient. That shouldn't be any problem. Next, after this, we're going to start solving equations by the process of completing the square. Be back in a minute. Now we're going to solve an exercise involving the process of completing the square. In this case, we're going to solve the following equation by using completing the square. As you can see in here, if you try to factor out the polynomial, you will see that there are no possible factors whose combination of 7 will give you 12. This is where we decide to apply completing the square. So how are we going to do it? Okay, we're going to start by leaving an expression that can be transformed into a completing the square process. And thus, this positive 7 goes to the other side as negative 7. Now you're going to see that I left an empty space in here because this is where I am going to complete my square. Now, what I am going to do, okay, we identify letter B. So this will be negative 12 divided by 2, which will give me negative 6, if you remember. And then what we are going to do is complete the square. So we take this expression that is negative 6 and we square the value, obtaining a positive 36. Remember, this element goes adding into the expression. So I take it in here as 36, but since I have an equation, what I do on the left side of the equation, I must do it also on the right side of the equation. So in here, this is my expression. Now I'm going to simplify the process that we have in here. We're going to have m squared minus 12m plus 36. All this equal to the operation 36 minus 7, or negative 7 plus 36, which will give me 29. Okay, now this polynomial in here on the left side of the equation is a perfect square trinomial. So we will do the process of factoring. M, the square root of this one, which will be 6, and the checking of the middle term, which will always be the multiplication of these elements. So as you can see here, we have the 12m and we have a perfect square trinomial. Therefore, I can simplify this as m minus 6 to the second power equal to positive 29. Now, here we are going to apply something that we learned previously with radical equations. We're going to apply the square root to the left side of the equation, and what I do on the left side of the equation, I have to do it also on the right side of the equation. Once I apply my square roots, you will see that these elements get cancelled, and my expression becomes m minus 6 equals to, remember this, very important, positive and negative square root of 29, which is part of solving a quadratic equation. And now we're one step away from the final answer. As you can see in here, m will be left alone. The negative 6 go to the other side adding. So it will be 6 plus minus square root of 29. In here, we can see clearly two answers. M1, which will be 6 plus the square root of 29. And M2, which will be 6 minus square root of 29. Now, these are numbers that are called irrational numbers, because when we try to find out the square root of 29, we end up having a sequence, not a sequence, okay? The number is kind of irrational. That's why we leave the answers like this, or simply we just write it like a solution set, as we are used to, and we simplify the solution set just by copying this element in here. 6 plus minus the square root of 29. Okay? Now, we must be very careful because we have to show that in here we have two answers for the quadratic equation, because quadratic equations always contain a maximum of two answers. Now, again, this is the process of completing the square, and in here we obtain the final answer. The next problem that we're going to do implies a value here that is different than 1. That means a leading coefficient that is not equal to 1. So I'm going to start that process. With another equation. The equation is this one. Problem number 2 will be 3x squared plus 7x minus 4 equal to 0. Okay? So, we're going to see what is the condition that we're going to have in this problem. Obviously, I have a 3 in here that is a leading coefficient. I need to eliminate that leading coefficient from the beginning. So, I can do it in here, or I can do it in a step forward, but let's do it right from the beginning. So we have now the following situation. X squared plus 7/3 of x minus 4/3. And if you remember, what we're going to do is leave this expression with the variables on one side and the constant term on the other side. So we're going to have x squared plus 7/3 of x equal to positive 4/3. Why I'm leaving this space in here? To do the process of completing the square. So what are we going to do in here? Okay, now that we know who is b, we take 7/3 and divide it by 2. This will give me 7/6 if we write it like a fraction. And then this will lead me to the process of completing the square. So I'm going to square the result, 7/6 in here, and the final answer will be 49/36. This is the element that goes filling up this little space that we left in here. So 49/36. And since I added in here, I am also going to add it on the other side of the equation. So we're ready now to perform these operations. These operations will give me, okay, this is a perfect square trinomial, let us remember, so we're going to factor it. The factoring of this one will be 7/6. And we're going to check the one in the middle by multiplying the first element and the last element by 2. Okay, and if you see in here, what we have is, 7/6. And 2 times 7 becomes 14. 14 divided by 6 is 7/3. So, no problem. We have x plus 76 all square equal to the result of this addition. And the result of that addition implies that we're going to look for the common denominator and we're going to simplify that element, okay? And this element, once you simplify it, becomes 97 over 36. Okay? And now we're ready to apply the process of the square root. Okay? So we apply, remember, the square root on both sides of the equation. To get to the final answer, we cancel this and we proceed to simplify. So we have x plus 7 over 6 equals to positive and negative the square root of 97 divided by the square root of 36, which is equal to 6. And now we are almost one step getting to the answer. This will become x equals negative 7 over 6 plus and minus the square root of 97 divided over 6. And if you see here, we have the same denominator, so I can still write my answer the following way. If I want to simplify it, here we already have the answer. But in algebra, we don't waste any time doing these operations. Negative 7 plus and minus the square root of 97 and this divided by 6. Why do I leave the square root of 97 like that? Because 97 is a prime number and it cannot be simplified by any other number. Therefore, it doesn't have an exact square root. This is the final answer. So now we're ready to write the solution set, which will be negative 7 plus and minus square root of 97 divided by 6 as my solution set to this problem. Hoping that you understood the process of solving a quadratic equation that implies a leading coefficient different than 1. Okay, I hope that you see all the process. Remember, we divide first all the equation by the leading coefficient, no matter what value you have in here, and finally we start the process. Don't get scared if you get to see fractions in the problem, because those fractions are all related, okay? There is always something that simplifies them. And in here we have the final answer. Again, this answer is what we call an irrational number, because this is not a perfect square. See you on the next video.